Okay, so this is from section 2.1 today, and we're working off the idea of what a function is. A function is any relation such that for every input x, for every x value, there's only one output or one y value. So if you see the same x being repeated, but they've got different y values, that tells me it's not a function. I want this to be a predictable quantity. That means that every time I get an x value, I can already predict what the y value should be. There shouldn't be any question left. So we're going to look at some examples of how we can tell. So we're going to start with number 7, and it tells us to list the domain values and the range values separate. Well, the domain values are just all of the x values that the relation uses. And so if I look at my x values, I say I've got a 5, I've got a 10, a 15, and a 20. And then my range values are just the y values. So domain, think about x. Range, think about y. And the range would be 20. Now that's written down twice. I don't need to write it twice, just once. And then 30 also appears twice. So if I look, this is my domain and my range. If I want to create a mapping, I would want to point from every input or domain value to the associated output. So input to output, input to output, and input to output. And notice that both of these are pointing at the same value, but this is still a function because 5 only has one output, and 10 only has one output, 15 only has one output, and 20 has one output. If these arrows were reversed and two things were coming from 15 and pointing to two separate things over here, then we'd have an issue. And we'll look at an example of that. Let's take a look at number 19. Here, we don't have to list the domain and range, but it's going to help me understand a little bit about why there's a problem here. So I'm going to list my x values, -1, 2, 4, -5, and -1 again. Well, I've already got a -1, so I don't need to write it twice. Over here, I've got -1, 5, 8, -9, and -5. Those are my y values. These are my x values. Now, if I go ahead and produce that domain or that mapping, -1 goes to -1, 2 goes to 5, 4 goes to 8, -5 goes to -9. Oh, and -1 also goes to -5. See, right here I have two different arrows starting in the same place. This tells me that I have a choice. -1 could go to -1, or it could go to -5. In other words, there's an input that has two outputs. So this is not a function because -1 has two outputs. Okay? Not allowed. Makes it a non-function. There's some other ways to tell if something's a function. It actually has to do with the graph. If I placed these all in a graph, -1, -1, and then if I come down to the other issue, -1, -5, both of them are literally stacked right on top of each other vertically. And that's going to cause us to reject this as well, using what's called the vertical line test. Here on 23, we're also going to try to use the vertical line test. The way we'll do that is we'll create a vertical line. Then we're going to take this vertical line and run it right and left and ask the question, does my curve here in black ever cross the green line more than once? Right here we'd say it crosses once. It's called a tangent. But as I move further and further in, notice that just about everywhere this is going to have two crossings. So this would fail the vertical line test and not be a function. And because it fails the vertical line test. Okay? If it crossed only once, we would say it passes, and so it is a function. Just a couple other problems we need to look at. Here we're also asked to do some graphing, some basic graphing. We have y equals -x plus 5. If we think about y equals mx plus b, we know that b, the y-intercept, is 5, and the m, the slope, is -1 or -1/1. Either one of those would work. So what I'm going to do is I'm going to start up here at 5. 1, 2, 3, 4, 5. And I'm going to go down 1 and over 1. I can do it again, but in the end, there's my line in each direction. All I want you to do is create that graph. Using this slope-intercept form, it's pretty easy, but you could also build an XY table and plug things like 0 in for x. That would give you a 5. And then 1 in for x. -1 plus 4, 5 is 4. So there's my second point. And so on. Plotting points and connecting the dots. The last part of the assignment is telling whether something's linear or not, and then substituting and doing some evaluation. First thing I want to notice is these exponents of 3 and 2. That tells me this is not linear. It doesn't mean it's not a function. In fact, this is a function. But it does mean that it's not linear. It doesn't make a straight line. Okay? It's going to have some bends and curves to it, which we're not worried about yet. We're not going to graph that today. Just knowing that it's not linear tells us that there's useful things that are going to be found out about it. But for now, we're more concerned about this substitution. See, the difference between g of x and g of -5 is that -5 has taken the place of x. So we're going to try and do that. Equals, parentheses, -5 cubed minus 2 times -5 squared plus 5 times -5 minus 8. We need to go through and simplify. -5 raised to the third power is -125. Here we have -2 times -5 times -5 is 25. Then we're going to have minus 5 times 5 is 25 minus 8. One small simplification, this is -50, -125, -25, and -8. If I add all this together, I end up with -208. And that is the value of g of -5. Okay? So not linear, and then we just do a substitution and evaluate. Okay? That's what the homework looks like. It won't always be this way, but for now it's pretty straightforward. So good luck, and we'll see you.